Welcome to 20 Fingers 2 Brains. In this video, we are going to discuss what is token-based authorization and how it works and what problems it solves. In short, token-based authorization is a mechanism used by applications to authorize its users on subsequent requests once the users are successfully authenticated to an application. By now, you must have noticed a quote on the screen, and it says that in order to understand or find a solution, it is important to understand the problem first. So we are going to follow this code and we will try to understand the root problem first, and then we will see how token-based authorization solves that problem. So the root problem is stateless HTTP. So the browser and the web server uses HTTP as a protocol to communicate with each other. So going back old days, there's no mechanism of maintaining a user state at the server side. HTTP is stateless. And stateless is one of the characteristics of HTTP protocol. The server doesn't maintain any information related to request. That's why the request should contain all the information required for that particular transaction or fulfillment of that particular request, because there would be no history of the previous request. So the same scenario we'll see through uh, an example. And in this example, I have a user and a static app. Static app is something which have static pages and it has got same response for each and every user and each and every request. So you basically request for a page 1 to the application, the application response processes your request, give you page 1 as a response. So in this case, there's no need to maintain any state since it's a static app. Next scenario is of a dynamic application wherein the response is different based on different user inputs and user access levels. In this case, the dynamic app needs to maintain user state and needs to have a login page so that it can authenticate the user. So you basically try to log into the application by providing your credentials. Application authenticates you and then process your request, give you page 1. Now suppose you are done with reading the page 1, now you want page 2. So application receives a request and the application, since not maintaining any user state, doesn't know you and it says, I do not recognize you, I cannot give you the page. Now since on the second request, that's a subsequent request, you are not authenticating or not providing your credentials, the dynamic app doesn't know you and cannot give you the response. So this is the problem where the applications are not maintaining the user state, and that causes the application or that causes the user to authenticate to application on every request. So we have to solve this problem first. And you might be thinking, like, when I went through my banking site or when I purchased something on a shopping site, I just authenticate it once and the application never asks me my username and password again. How that happens? So that happens because those applications are using a mechanism which maintains the user state and making look like HTTP as a stateful protocol. So we'll solve this problem of no state by having a mechanism. We'll discuss two mechanisms, and the popular two mechanisms are session ID plus cookie. That is a stateful where the state is maintained at the server side, and we have a JSON Web Token approach wherein the state is not maintained by the server side. Okay, so our initial problem is no state, that is solved by session ID plus cookie that we are going to see now. So before going to the actual technical implementation of session ID plus cookie, we'll just see how the real world scenario is for the social token. So which basically matches with that session ID plus cookie approach. So now in this scenario, you are a user and you are not able to access your internet service and you're going to call your internet service provider customer desk. You raise a complaint. So customer desk personnel basically collects all your information, logs a complaint in the system, generates a complaint ID or a reference ID, give it back to you. Now this reference ID is very important because that reference ID is unique to you and unique to your complaint and can be used for future communication or transactions. So suppose Next day, it's still not working. You call back the customer desk again. So customer desk personal, even if the personal has changed, he'll ask you for a request ID. So you just have to give request ID. It will look up that request ID in the system and it will get all your information there and then he can basically process your request. So in this scenario, your state is maintained by the customer desk on the server side. You can say it gives you a reference ID which basically connected to your state and then it asks you to get that request ID whenever you come next. So on the same analogy, session ID plus cookie works. Now let's see how it works. So in this case, I'm being the user, I have a dynamic application, I log into the application, providing my credentials, ask for a page one. Application authenticates me, checks whether I'm a valid user in their database, generates a session for me, and then assign a session ID which is unique to that session. And that session ID would be unique to me as well and gives it back to me. That session ID is stored in the browser as a cookie. That is why I have named it as session ID plus cookie. And tells me that give me this session ID on the next request so that I can authorize you with the application. So on the next request, this session ID would be sent in the request header. The application will use the session ID to look up my session state in the server's memory where the sessions are maintained, session state is maintained. It will verify me, identify me as a user, authorize me, and then basically process my request saying, please take your page. So this is how session ID plus cookie works based on our previous analogy. Now this is a scenario of an application deployed on a single server. Now these days we have applications deployed on multiple servers spread across multiple data centers in different countries. We call it as distributed applications. And in this scenario, we have a user and it is going to interact with an application which is deployed on three servers. And there is a load balancer which is at the top of the three servers. So load balancer is basically distributing the load evenly to the servers based on their availability. Now I suppose it send a request. That request is sent to web server 1. I authenticate with web server 1. So web server 1 basically creates my session, gives me session ID, and then on the next request, I ask for page number 2. My session ID is sent. Now the load balancer send me to server 2 because server 2 is now available and server 1 is busy. But since I am not authenticated or my session is not created with server 2, I have to authenticate it again. Same will happen if I redirect it to server 3. So by this way, you have to authenticate again and again, and your session would be maintained at different servers, which is overhead on the servers. So this scenario can be basically improved by having a common server which will have your shared session. So whenever your request goes to a particular server, your session would be created on a shared server, and then every time on a subsequent request, a lookup or you can say a query would be sent to the shared session, and then your session information would be given to the web server, and then your request would be processed. Now, there are certain problems with this approach, and one being is basically you need to have a separate server for shared sessions. There is overhead of looking to the shared session and then processing a request, and then there's a single point of a failure. So basically, if the shared session server goes down, then all the sessions would be killed for the application. So this scenario of having a shared session would can be improved by having another approach that is called as sticky sessions. So in sticky sessions approach, basically each server will have a session state maintained at the server itself, and load balancer is configured for sticky sessions. So if your request goes to web server 1, you authenticate with web server 1, your subsequent request would be sent to the web server 1 itself, not to another servers. So by this way, it is maintained that your session is maintained at a single server and you would be redirected to the same server again and again. So you don't need to have a dedicated server for session state, and then your session state would be at a single server. The load would be less. So these are the different approaches we've seen with the distributed application, and we've also seen how session ID plus cookie helps us to maintain state of the user. But there are some problems with this approach, and I've listed on some of the problems, like the application is not scalable. Now suppose you have to introduce one more server, then you have to think of how you will maintain the session state for that server. The session ID approach won't work well in microservices architecture. That's true, because microservices architecture is based on different servers for different small microservices. Cookie carrying session ID won't work well in cross-domain scenarios, and this approach has performance overhead in case of large number of users accessing application at the same time. Now suppose large number of users are accessing a application at the same time, then the server has to maintain a lot of session state at a single point in time. It has to look up that session state. So that's an overhead for the servers and also degrade the performance. Now we will see how token-based authorization helps to improve this scenario, and we'll see first an analogy, which is a better approach compared to server maintaining the session state. And in this analogy, the customer desk is not going to maintain any data, and I've named it as a JW2 analogy. So you basically raise a complaint to the customer desk personnel, and the customer desk person basically will not log your information into his system, but rather write details on a paper and hand that paper to you, and no information stored at his side. So he will tell you, like, take this paper, when you come in next time, bring that paper to me so that I can have all the information about you. Now this approach has some problem, like now that paper is a normal paper. You can have any paper, write it down whatever you want and take it to the customer desk. And you can use that scenario to for your use or for your benefits. In that case, the user personal customer desk needs to have a signature on that paper, and when you go to that customer desk person next time, he will validate that signature to make sure that you are a valid user. So on the same lines, the token based authorization works. So the server is not maintaining the state. He's basically generating a token which will have enough information to authorize you on subsequent request, and has handed the responsibility to you to send that token back to the server. Server will just validate the signature and authorize you and process your request. So let's see that. So again, I have a user and a dynamic app. I will log into the application by giving username password. Application will authenticate me by checking against the database details. If I am successfully authenticated, the server will generate a JWT token in a JSON format. That JWT token will have enough information for me to authorize in the subsequent request. That token is sent back to me. I will store that token. That depends on me. I can store it in cookie or a local storage. On the next request, I will send that token in the as a part of a request. We'll see how we can send that in upcoming videos. But then that JWT token is sent to the server. Server will verify the signature on that token. It will identify you as an authorized user, and it will process your request and returns you the response. So this is how JWT solves the problem of overhead on the server side of maintaining the user state. Okay, and let's see what happens in the case of a distributed application. So in this case, I'll authenticate to the application. The application would return me the JWT, which will have all the information to authorize me, and this JWT is signed with signature. Next request, I will send the JWT, and even if that request is sent to web server 2, server 2 knows how to validate that signature, and it would process my request based on the checking that signature, and you just have to pass JWT. By this way, you can add any number of servers. There won't be any problem of scaling. So applications are easily scalable. So this is how JWT helps us to improve the condition of scaling, and also helps us to remove the overhead from the server side to the JWT token. Now that becomes the responsibility of the user to send it on each request. So let's see what we have seen in this video. So the summary part. So we've seen like HTTP is a stateless protocol. That state can be maintained using session ID plus cookie, helps us to authorize users by maintaining state, and that has some drawbacks. That drawbacks are solved by JWT token approach, which helps us to authorize users by not maintaining state on the server side. And by that, the applications are scalable and there's no performance head on the servers. In the next video, we will see what is the structure of JWT, how it is formed, and how it is signed, and what is signed tokens, and how the server side verifies the JWT, whether it's a genuine JWT with signature or it's a forced JWT. I hope you like this video. Thank you, friends.